Hey everybody, this is a continuation video before the upcoming chemistry quiz. I uploaded the first video to YouTube, the more lengthier version where we discussed electron configurations. Please go check it out at my YouTube channel. Also, please subscribe. I will link my YouTube channel, or show you guys my YouTube channel at the end of this video. But this is going to be a shorter video discussing some of the smaller topics that have been briefly discussed in class. So again, here we have orbital diagrams. For example, we have oxygen, 8 electrons. The electron configuration is 1s2, 2s2, 2p4, and this is the orbital diagram. 2 electrons in the 1s, 2 electrons in the 2s, and 4 in the 2p. These arrows should always be in opposite directions, indicating that the electrons have opposite spin, and we are always filling in these orbital diagrams from left to right. So for example, we have 2p4, 1, 2, 3, back to the left for number 4. Here we have valence electrons and core electrons. Valence electrons are the electrons in the outermost energy level, or the shell of an atom. They are the ones that are involved in chemical bonding and reactions, and the number of valence electrons determines the atom's chemical properties and reactivity. So for example, in sodium, which has an atomic number of 11, how this relates to the Bohr model, as 2 electrons in the first shell, 8 in the second, and 1 in the third, and this 1 electron in the third energy level will be the 1 valence electron, since it is in the outermost energy level of this specific atom. Moving on to core electrons. Core electrons are the electrons in the inner shells, exactly the opposite of valence electrons, and are not involved in bonding. They are closer to the nucleus and shield the valence electrons from the full positive charge of the nucleus, and they do not significantly affect chemical reactivity. For sodium, again, the core electrons are going to be the 2 electrons in the first shell and the 8 in the second shell. Shorthand electron configurations. We already discussed the actual electron configurations in the previous video. Go check that one out if you haven't already. And basically, these shorthand electron configurations are going to be used for atoms higher up in the periodic table where they have many more electrons, and writing their electron configuration would be much more time-consuming and lengthier. So for example, we have sodium. We are going to take the nearest noble gas before the element on the periodic table. So the nearest noble gas to sodium is going to be neon. As you can see, sodium is over here, 11 electrons. Neon is the closest one. If we had iron, for example, Fe over here, the nearest noble gas will be the one behind it, which is going to be argon. So the shorthand electron configuration is going to be neon in brackets and then 3s1. I hope this makes sense, but we already discussed this in class today. Basically, we're using one of the previous noble gases to shorten all of the electron configuration terms before sodium. I hope I made myself clear, but please ask your teacher for any assistance if you don't get it. That's the best way I could possibly explain it. So here's some practice problems with the electron configuration. So I want you to write the electron configuration for strontium, Sr, 38 electrons. This one, I want the full electron configuration. And then for the second one, I want the shorthand electron configuration for tantalum, Ta, 73. I do not have the answers in the slideshow. You can easily just search them up. So go ahead and give those a try. Pause the video. I'm going to be moving on. So thank you. This was it. Again, I told you guys it was going to be a shorter video, but please support me by subscribing to my YouTube. Here's my YouTube, just my full name. I only have 19 subscribers. Hopefully I can get more by the end of tonight, by the end of tomorrow. And again, thanks Ian, thanks Josh for this idea to expand my videos on YouTube. I'm going to be posting all my physics videos from last year to this YouTube channel, and all of my chemistry videos for this year will also be uploaded in a timely fashion. Thank you guys so much, and I hope you do well on the upcoming quiz.